What's going on, guys? John Alder here from Codemy.com, and in this video, we're going to load our data and train our model for our neural network with PyTorch and Python. All right, guys, like I said, in this video, we're going to load our data and train our model. But before we get started, if you like this video and want to see more like it, be sure to smash the like button below, subscribe to the channel, give me a thumbs up for the YouTube algorithm, and check out Codemy.com, where I have dozens of courses with thousands of videos that teach you to code. Use coupon code YouTube50 to get 50% off lifetime membership. It's all my courses, videos, and books for a one-time fee, which is insanely cheap. Okay, in the last video, we defined our model. In this video, we're going to load in our data and start to train and test our neural network here. So let's come down here. I've got the same file we worked on in the last video, simple_neural network. So go ahead and check that out. As always, you can find a link to the code in the pinned comment section below, as well as a link to the playlist with all the other videos in this series. So check that out if you haven't so far. All right, so very quickly, let's import matplotlib because we're going to make a little chart later on at the end, and I will probably forget it then, but we just go ahead and do it now. So let's go import matplotlib.pyplot as PLT. And then we need to put the little percentage sign and then matplotlib inline so that we can actually do our charts in our Jupyter notebook here. Go ahead and run that. That should be fine. Like I said, we'll do this at the end of this video, but I'll forget about it by then. So let's just go ahead and do it now. So we're also going to need pandas to load our data. So let's go import pandas as PD. And I've got a whole playlist on pandas and matplotlib on the YouTube channel. Check that out if you're interested. You don't really need to know pandas in order to do this. I'll walk you right through it. We're just going to do one little thing. So now let's create a URL to load our data. There's lots of different ways you can load your data, but we want to create a data frame. So let's go my_df. Again, if you don't know what a data frame is, check that pandas playlist. I go into that in great detail in that. And we're just going to call a pandas.read_CSV. And then we're going to pass in that URL. Now, what is that URL? Well, we don't have that yet. Like I said, there's lots of different ways you can load our data, but we're going to be using the iris dataset we talked about in the last video. So let's head over to Google and type in iris dataset. Now, we looked at this in the last video, I think. Let's come down here. That's iris dataset, GitHub. If we click on this, yeah, this is it. So here's our four features, right? Sepal length, sepal width, petal length, and petal width. And then the variety is the output, right? So it's Setosa, and then versicolor, and then Virginica. So this is okay. We don't really want these names for this last column. We're going to change this into numbers. So Setosa will be 0, the other one will be 1, and the last one will be 2, but we'll play with that in a second. Let's just come over here and click on this raw link. And yeah, this will do. Let's just copy this whole thing, pop it into our URL. There we go. And then that's it. We can run this, shift enter to run it, and we're good to go. Our data has been loaded. And we can tell that we're going my_df, and boom, here we go. We've got our sepal length, sepal width, petal length, and petal width, and then the variety. So very cool. Starts out with Setosa, ends in Virginica. That versicolor is somewhere in the middle there. That looks good. We could also just, dot head this if we wanted to, just to get the first 5 things. Or we could dot tail this to get the last 5 things, whatever, however you want to look at it. Looks good. So now, very quickly, let's get rid of these words here for this last column and change it to numbers, because we're going to be doing machine learning, and machine learning works better with numbers, of course. So let's just go my_df, and we want to change that last column, that variety column. We want to set it equal to my_df variety, and let's dot replace. First off, we'll replace Setosa with 0.0, or you could just do 0. Doesn't really matter. Let's copy this a couple of times. The other one is versicolor, so that's versicolor, and that's going to be 1.0. And then the last one we could see above is Virginica, and we want to make that equal to 2.0. So let's go ahead and my_df to print this out. That looks like it worked. Now we have 0s, 1s, and 2s in our last column, and we're good to go. Now let me go ahead and comment this. Change last column from strings to integers. Well, it's not really an integer, but we're going to use it as an integer later on, so good enough. So, all right, shift enter, run that guy. All right, so now let's start to train, test, and split things. Right, so we need to set an X and a Y. So our x is going to equal my underscore df dot drop. And we want to drop that last column. So let's go variety. And since this is a column, we need to set the axis to 1. Remember back from our Pandas playlist, explain why that's necessary. And the reason why we're dropping this is because, remember, these first 4 things are our features. So our x is always the feature. The y is always like the outcome, right? So you're going to say, hey, we've got a bunch of features, petal width, petal length, and those are going to determine the variety, the outcome, the y, right? So x is features, y, and it's usually an uppercase x and a lowercase y. It's just the convention. It's going to be my underscore df, and we want the y to be the variety column. Alrighty, so that looks pretty good. Now, if we just look at x, it's going to be a data frame, right? So we really want to convert these to NumPy arrays. And so let's just set x equal to x.values. And same thing, y will be equal to y.values. And remember, capital X and lowercase y. There we go. So now we can look at x again, and now it's just, it's just a big NumPy array, which is what we want. So, all right. So now in order to run our train test split, we need SciKitLearn. Again, check my Pandas playlist if you're not sure what all this is about. I go into that in detail there. But we could just go from SciKitLearn.model underscore selection. We want to import train underscore test underscore split. Right? That looks good. Shift enter to run that. And now let's run our train test split. So we're going to need a few things. We're going to need x train and x underscore test. We're also going to need y train and y underscore test. And we're going to set those equal to train underscore test underscore split. And that's just what we just imported right there. And then we're going to pass in our x and our y. And we want to set our test size, probably to like 0.2. So remember, we're going to be training and testing. And our test size is going to be 20%. And our train size is going to be 80%. It's going to equal 100%. So we could designate that by setting the test size to 0.2, 20% basically. So Pytorch knows that the other thing is whatever's left, 80%, right? So, all right, now we also probably want to set the random underscore state. And I'm going to set that equal to 41 because I always do. You don't have to do that, but if you're following along with me and you want your random stuff to kind of end closely looking like what my random stuff does, you start out with the same random state as I'm doing, and that'll keep all that straight. So, all right, let's go ahead and run that. That looks good. And this is all kind of starting to scrunch together, maybe kind of hard to read. I have to scroll. You can always check the code in the link in the description below. So, all right, we've got our train test split. Now we need to convert these things, they're NumPy array type things. We need them tensors. So let's go x underscore train. And this is going to be a torch dot float tensor. And we just want to pass in an x train. Why do we want this to be a float tensor? Well, because remember up here, these x things are all decimals. That's a float. So 1.4, right? So we'll do that. So that works with x train. We want to do the same thing with x test. So let's just kind of change that to test and that to test. So let me just comment convert x features to float tensors. And we also want to convert the y labels to tensors as well. But we probably want long labels for this. So let's go y underscore train. That's going to be equal to torch dot. Let's go long tensor. And that's going to be y underscore train. And we can just sort of copy this whole thing. And this one's going to be test and test. So why long tensors? Long tensors are 64-bit integers, right? And remember up here, I set these at 0.0 and 1.0 and 2.0. I probably should have just went 0, 1, and 2, but I don't know, my brain. Everything else was decimals in this table, so I put those as decimals. But we're going to now convert them into integers because we just really care if they're a 0, a 1, or a 2. We don't care that they're 0.0, 1.0, and 2.0. Doesn't really matter. So we're going to use a long tensor for that. So let's go ahead and shift enter to run that guy. All right, we're good to go there. So now we need to set the criterion of our model to measure the error, which is basically how far off the predictions are from the data, right? So to do that, I'm going to create a variable called criterion. If I can spell it right. There we go, criterion. And this is going to be a neural network dot cross entropy loss function. That's just what we're using for this model. So that works there. And then after that, we need to choose an optimizer. Because, you send your stuff through and through and through and through, and it optimizes, and it learns, right? So we need to choose an optimizer, and we are going to use something called the Atom optimizer. There's a bunch of optimizers you can use. This is a popular one. That's what we're going to use. We also need to set our learning rate, right? So learning rate equals learning rate. And what the learning rate is basically if our error doesn't go down as we learn, like after a bunch of iterations, also called epochs, we'll get into that in a second, we probably want to lower our learning rate, right? So let's create a variable. I'm going to call it optimizer. And this is going to be a torch.optim, not opt-in. I used to do a lot of marketing, and there's opt-in email. So I always want to type in opt-in, like we're opting in to the newsletter, right? It's optim. So torch.optim. We want the Atom optimizer. And then we want to pass in our model dot parameters. We'll look at those in just a second. And then set our learning rate. We'll just set that equal to 0.01. So remember up here I said, if we run this through and our error doesn't go down as much, and we'll see this in a minute, then we're going to come back here and change our learning rate. You might add another 0, right? And the lower your learning rate is, the longer it's going to take to learn, the longer it's going to take to train your model. So, that's not a big deal for us. We've got basically 150 rows of data. It'll train very fast. But if you've got millions of rows of data, tweaking that learning rate, making it lower, might take a whole day to, train your model more. So keep that in mind. So, all right, what are these model parameters? Well, if you remember way back in the last video, we have basically 3. We've got the FC1, FC2, and our output. So this is our neural network. It's layer 1, layer 2, and then the output layer. So we're passing those things in. We're basically saying, hey, an epoch is sending the data through all of that once. So it goes through layer 1, then it goes through layer 2, then it goes to the output. That's one epoch, one iteration, right? So we're gonna create a bunch of iterations, we'll see in just a second, and optimize every time we go through to try and learn, right? So that's basically what all this says right here. So, all right, that looks pretty good. We could shift enter to run this, no errors there. And if we wanted to, we could go model.parameters and just kind of output this to see. Again, there's FC1, FC2, and our output, right? So our layer 1, our layer 2, and then our output layer. So that's what these guys are there. So, all right, looking good. Now, it is actually time to train our model. So the first thing we need to do is determine how many epochs do we want, right? And an epoch is one run, like I said earlier, through all the training data in our network, right? So we're sending all of our training data through the network one time, basically. So, I don't know. I think I'm going to set epochs equal to 100. We're going to spin it through 100 times. If that doesn't look like it works, we might raise it to 200 or lower it or whatever. And we'll see in just a second whether or not it does work, all right? We'll learn how to do that. So as we're going through here, we want to keep track of our losses, our errors, because we want that loss to kind of decrease over time. That's how we know that the model is learning, that the network is learning. So I'm going to create a variable called losses. And it's not really a variable, it's going to be a Python list, and we'll append our losses to that list as we go on. So, okay, so let's get into this. Let's go for I in range of epoch. So for each number of epoch, we want to send everything forward through our neural network, right? So to do that, let's comment go forward and get a prediction. So let's go y_pred, short for Y predictions. Remember, we're trying to predict the type of flower, right? Is it a versicolor? Is it a virginica? Is it versicolor? Is it a Sarah, whatever, Setosa, versicolor, or virginica? A 0, a 1, or a 2, right? So that's what we're trying to predict. And to do that, we send our data model.forward through the neural network. And what are we sending through? Our X_training data, because we're training this thing, right? So we're going to try to get predicted results. So we're going to send through, the sepal length, the sepal width, the petal length, and the petal width, and then try and use that information. The neural network's going to try and use that information to learn what type of flower it is, right? And that predicted flower type is our Y-pred, right? That's the prediction. So, all right. Now, we also want to measure the loss or error, same thing. And it's going to be high at first. And we'll see that in just a second. But we can measure this by creating a loss variable. And this is going to be our criterion. And we're going to pass in the Y_pred, the prediction, versus the Y_train. So this is going to be the predicted value versus the Y-train value, right? Okay. We also want to keep track of our losses, like I said earlier. And like I said earlier, you don't have to do this, but it's going to help us determine whether or not this thing is working correctly or not. So it's a good idea to do this, right? So let's go losses.append. And remember, that's just this empty Python list we created. Every time we have a loss, we want to append that on there. So we would just append in the loss, right? Now, later on, we're going to take these losses and graph them out. And I think the loss is going to be a tensor. And let's turn this back into just sort of a number or a numpy type thing. So we could do that by loss.detach. And then we want to detach as a numpy. I think that should work. Yeah, probably work. We'll see in a second. So, okay, moving right along. Now we want to print, let's say every 10 epochs, just to sort of see some data to see, what's going on here. So let's go if I modulus 10 equals 0. So every 10 epochs, 10 divided by whatever is going to equal 0. We'll know that that's every 10 epochs, basic Python. We want to just print. And let's create a little f string, and let's go. We want to print out what number of epoch are we on. So that'll be I. And let's say, and the loss that'll just be loss. Okay, very cool. So now the only thing left is to do some back propagation. And back propagation is hard to explain. You take the error rate, right, moving forward, of forward propagation, and you sort of feed it back. Let me go on another line here, through the network to fine tune the weights, right? So as we get an error, we kind of feed it back into the network, and the neural network uses that to tweak its weights to learn better or learn more, or maybe just to learn at all. So we want to set our optimizer .0_grad. That's just a function. We also then want to set loss.backward. That's a function. And then finally, we want to set optimizer.step. And every time we're stepping forward here. So, all right, let's go ahead and run this. And oh man, we got an error. Name epoch is not defined. We set that to epochs. Epochs. Right. So let's see. For range and epochs. All right, there we go. That should work. Shift enter to run this, and boom, here we go. So this is starting at 0. Our loss is 1.12. So that's pretty high, right? And then it goes through 10 epochs, and the loss is going down. It's dropped almost 0.12. Then after 20, it's dropped down to 0.81. After 30, 0.5. Down to 40, 26. And now you see right around here, somewhere around 60 to 70, we're dropping only 0.05. And then from there, it's 0.04. And then from there, it's like 0.02. So it's steep at the beginning, and then it's sort of flattening out. And we can see this if we want. So let's graph this stuff out. So let's go plt.plot. Let's create a little graph here. And let's just set the range of epochs and set that versus our losses. And if we want to create a little label, we can do plt.ylabel. And that's going to be our loss/error. And we can also go plt.xlabel, and that's going to be our epoch. So if we run this, boom, we get this very nice graph. And you can see it starts up pretty high because, at the beginning it's 1.12, which is pretty much what we're seeing right here, 1.12. And you'll notice it's going down. This whole side here is going down to 0. And as the epochs kind of cycle through our neural network, as it's training, this is dropping until it gets to about, like I said, 60 to 70. It starts to kind of flatten out. And now we are kind of moving kind of close to 0. And this will just flatten out the more epochs we do. And we want to see that flattening. That means we've trained, we're learning, whatever. And if we're not seeing that, well, we would come up here and tweak our learning rate. Where was that? Right here. We might change that. We might add more epochs. We could easily change this to 200 epochs. Come up here and run all these guys again. And now you see we go to 200 epochs, but same deal. Around 60 to 70, it kind of starts to flatten out, and then it gets very flat as it goes closer to 0. It looks like a limit going to 0, kind of, right? So, yeah, it looks like we're good to go here. I'm going to change this back to 100 because, we don't really need 200. Run all these guys again. And we are good to go. So this is what we want to see. We want to see it steep at the beginning as it's learning, and then it kind of flattens out. That looks good. And we're good to go. So this video is getting pretty long. I think in the next video, we'll go ahead and validate our model, and then we'll start to classify totally new data by, putting in other flowers and saying, hey, what kind of iris is this? Start to do that in the next video. So that's all for this video. If you liked it, be sure to smash the like button below, subscribe to the channel, give me a thumbs up for the YouTube algorithm, and check out Codemy.com where you can use coupon code YouTube50 to get 50% off lifetime membership. So that's access to all my courses, almost 60 courses, thousands of videos, and the PDFs of all my best-selling coding books. Join over 170,000 students learning to code just like you. My name is John Elder from Codemy.com, and I'll see you in the next video.